Good evening and welcome to Monochemistry. Today we're going to go through a step-by-step guide to drawing Lewis dot diagrams. This step-by-step guide will allow you to draw all Lewis dot diagrams except for those that break the octet rule. The question today is we're going to draw the Lewis dot structure for carbon dioxide. The very first step is to determine the total number of valence electrons. In order to do that, we need to be able to write down the correct chemical formula. I'm going to go ahead and use orange for a color here. So the correct chemical formula is CO2. Okay, so if you use your periodic table, you'll see that carbon has 4 valence electrons, and oxygen has 6. Since there's 2 oxygens, I'm going to add 6 twice. If I add those up, I'm going to get a total of 16 valence electrons. Now, that number of valence electrons is the total we're going to have in the end. If we have more or less than 16 electrons, then we did not draw the structure correctly. Step 2 is to draw a structure skeleton with one bond between each atom. Now, we've learned that the element that goes in the middle in a compound of like CO2 would be the one that there's less of, but also the one that can form the greater number of bonds. Carbon can form 4 bonds, while oxygen tends to only form 1 or 2, generally 2. So carbon in that case would go in the middle because it can form the greater number of bonds. So what I would do in this case to draw a skeleton structure would be a carbon here and an oxygen on either side. And I'm going to go ahead and put one bond between each, like so. This is my skeleton. Okay, so there's my skeleton. What I'm going to do now is I'm going to place electrons around each element until they all have 8. So I'm going to go 1, 2, 3, 4, 5, 6, 3, 4, 1, 2, 3, 4, 5, 6. Okay, so now each element, whether they're sharing them or not, has 8 electrons around it. Now, I have to double check to make sure they have the correct number of valence electrons. Remember, 16 was the amount that I was supposed to have. If I have 16, I'm finished. If I don't have 16, then we're going to move on to step 4. So let's quickly count these. Got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Well, I think I went a little overboard. I think I have too many. I'm supposed to have 16, I've got 20, so this isn't right. So I have to figure something else out. So let's move on to step 4. Step 4 says to erase or add electrons as needed, and then manipulate those existing electrons to ensure every element has 8. So let's redraw what we had. We had C, O, O, and we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, for a total of 20. So I need to eliminate 4 of those electrons. So what I'm going to do is I'm going to go ahead and I'm going to eliminate the ones. Now, this comes by experience. How do I know which ones to eliminate? It really doesn't matter, but I'm going to go ahead and I'm going to get rid of these ones that were here. See, I'm going to erase those. Okay, now they're gone. Okay, and the reason I know to do that is because I've done this a few times. But as you get more experience, you'll kind of be able to feel which ones you should erase. In this case, I'm going to erase those ones because I know I'm going to have to share more electrons, and I'll get to that in a second. Now, I can manipulate the existing electrons. Now that I have 16, I can manipulate them. You'll notice that each of these oxygens has 8 electrons around it. This carbon, on the other hand, only has 4. So what I have to do is I have to move the existing electrons over such that carbon ends up with 8, and each of the other elements ends up with 8. Okay, so here's what I'm going to do. I'm going to go ahead and I'm going to move these electrons, get rid of those, and I'm going to go ahead and I'm going to put them in here. Notice now that this oxygen still has 8. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Carbon only still has 6 though. So let's go ahead and let's do the same thing on the other side so that oxygen ends up with so that carbon ends up with 8. Okay, now look, carbon has 8. This oxygen has 8. And this oxygen has 8. And that, in a nutshell, is how you do a Lewis dot diagram, specifically for covalent. If you wanted to turn this into a line diagram, folks, this is what it would look like. Every 2 electrons equals 1 bond, so this would be a double bond to this oxygen. And there's 4 lone pairs are still there, and the same on the other side. Okay, so if you have any questions about this, make sure you bring them to class, but that is how you do it. If you follow these instructions, you won't get it right the first time every time. Use pencil, please, for the sake of your sanity and probably mine. Use pencil, because you're going to make mistakes. But once you get the hang of it, it starts to go a lot quicker. So don't be frustrated if you can't do it the first time. It's kind of like a puzzle. You got to play with it a little bit, figure it out.